Hello everyone, welcome to the BOOKphilic YouTube channel. Now in this video we are going to discuss about the different phases of compiler. So the different phases of compiler can be represented in this way. Okay, so at first we are having our source program. So what is source program? We have already discussed in our previous video lectures. Now in this video we are going to discuss the different phases, inputs and outputs and their respective functions. So here are the few examples discussed in later on. Okay, so now the number one is source program. So for your reference, let me make you understand that whatever you write, whether it is C program, okay, C plus plus, okay, C sharp, or Java, these all language are programming language, high level language which requires compilation process. So in the compilation process, this needs to go through these all phases. So at first the source program will be taken as an input to the lexical analyzer phase. This is nothing but the phase. Okay, so what is the phase? Phase is nothing but the sequence of stages. So first phase is lexical analyzer phase. So and the second phase is whatever will be the output of the lexical analyzer will be taken as an input to the syntax analyzer phase that we have discussed yesterday. Now, in the syntax analyzer phase, whatever will be the output will be taken as an input to the semantic analyzer phase. And in semantic analyzer phase, what will be the output will be taken as an input to the intermediate code generator. Now, intermediate code generator, what will be the output? It will just go through the code optimizer and at last it will generate the synthesis phase. It will go to the synthesis phase and will generate the target program. In this way, the phases of compiler goes on. Now, what are the inputs and what are the outputs? It will be discussed in this video. So let us start with the phases of compiler. Okay. So at first we are watching that source program is taken as an input to the lexical analyzer. Okay, no problem. So from source program lexical analyzer will take out the tokens which will be the output of the lexical analyzer phase. That's it for the lexical analyzer. Okay, now how tokens are counted, how tokens are created, what is token, or have already been discussed in our previous videos. Now the tokens will be considered as an input to the syntax analyzer and it will generate the parse tree. What is parse tree will be discussed in our upcoming videos. It has not been discussed yet because there is no need of it till now. But in the upcoming videos, we will be discussing about the parse tree. For the time being now, you just need to know that tokens will be taken as an input to the syntax analyzer and it will generate the parse tree. This parse tree will be taken as an input to the semantic analyzer phase and it will generate the verified parse tree. Yes, you are listening to me correct. That what is verified parse tree? A parse tree which is already verified is known as verified parse tree. Verified parse tree. Okay. So this is a verified parse tree which will be the output of the semantic analyzer phase. Now we will be taking the verified parse tree as an input to that intermediate code generator, and this intermediate code generator will generate the intermediate code, IC code, intermediate code. It will generate the intermediate code, and after that code optimizer will take the intermediate code as an input and it will optimize the code whether there is any optimization or not. So this phase is optional in these phases of compiler, but here it is written as not a compulsory, but you may take it as a compulsory stage, because if there is any necessary of optimization of the parse tree or intermediate code generated through the intermediate code generator, then it will be in the need of the optimization. So after the optimized code that is generated from the code optimizer, it will get into the code generator phase. Now before code generator phase, so it will come into the code generator phase. Okay, this is the code optimizer that has optimized the code, and this is the code generator that will take the optimized code as an input and will generate the target program. So at last .exe file, that is executable file, will be generated, which can be easily run without dependency on the architecture of the computer or operating system that you are using in your computer, PC or laptop. That's it about the phases of compiler. Okay, now there are some few things that you need to remember is that here, from lexical analyzer phase to intermediate code generator, it is known as the front end of the phases of compiler. Front end of compiler. Okay, and from code optimizer to code generator, these two are known as backend of compiler. Okay, now what do you mean by front end and what do you mean by backend? So basically, front end means if the front end process completes, if the front end process has completed by the compiler, then you can easily it after this intermediate code generator. There will be an output of relocatable machine code. Machine code that will be then optimized by the code optimizer. So IC code, intermediate code, is also known as relocatable machine code. So relocatable machine code can easily be relocated from one computer to another computer, and without a front end process, it can go through the optimization, generation, and then target execution program. So no need to execute these four steps again and again. So if you have written something hello.c, this is the program that you have written hello.c, so you don't need to compile it again. You will be getting intermediate code, okay, that is also known as relocatable code, and you just have to move it from one PC to another, and easily you can run it on the another PC without the front end compilation process. That's why it is known as front end. It is a compulsory process, and it is based on the architecture and operating system of your PC. But whereas we discuss about the back end, it is not dependent upon the architecture and operating system of your PC. So that is known as backend. Okay, so it is known as a front end and it is known as backend. And what do you mean by symbol table manager and error handler? So the execution of your program while the execution of your program, if there is any error or warning found in between the compilation process, then it will go through the error handler. Suppose you have given the source program into the lexical analyzer, and lexical analyzer has taken out the tokens but has found some errors and mistakes, then it will just go through the error handler and it will generate the error code error code Okay, this error code will be shown to the programmer, and the programmer will just resolve the error which is present in the source program, and then it will again go through the syntax analyzer, semantic analyzer. In this way, this error handler process will go on. Okay, now symbol table manager is nothing but it is a box which is consisting of different symbols. Whatever you are using or rules or regulations of creating your source program, that will go through this symbol table manager and will get validated whether the rules or syntax whether you have written or not correctly or not. Okay, so this is the symbol table manager, okay, which will manage your symbols. And error handler is nothing but will be handling the errors that after compilation your program will generate. Okay, this is how the phases of compiler goes on. Now I have just written some points regarding all the phases of compiler. You just need to read it at once, or you may write it at your notes for your short notes. Okay, once you have read all these points, you will be understanding these all phases of compiler. So let us start reading lexical analyzer. First one is lexical analyzer. So lexical analyzer is the first phase of a scanner that works as a text scanner. So as I have told you that it will just scan the program and will generate the tokens. So this phase scans the source code as a stream of characters and converts it into the meaningful lexemes. Meaningful lexemes is nothing but the tokens that we have discussed in our previous video. Now, lexical analyzer represents these lexemes in the forms of tokens. As I have just discussed, so these 3 points are more than enough that you have to know in order to answer the examination questions, college exam questions, or interview preparation. This is more than enough that you need to know about the lexical analyzer phase. Basically, the inputs and outputs are being asked in the college level examination, and what are the function of lexical analyzer, this is being asked. So till now lexical analyzer, these 3 points are more than enough for lexical analyzer phase. So let us discuss the another phase, that is syntax analyzer. The next phase is called the syntax analysis or parsing. Okay, it is the second phase that is written over here. The second point is that it takes the token produced by lexical analysis as an input and generates a parse tree. That I have already told you that it will just take the input which is the output from the lexical analyzer, and it will generate the parse tree. Parse tree is also known as syntax tree. It will be read later on. So let us move on to the next phase. Next point, that is in this phase token arrangements are checked against the source code. What does it mean? Okay, so let me clear the all messy parts, because if this is messy, then you will not be getting understand. Okay, in this phase, token arrangements are checked against the source code grammar. That is, the parser checks if the expression made by the tokens is syntactically correct or not. So I am just giving you few examples in order to make you understand what does it mean. Means this line. What does it mean to say? This line means to say what? So you will be getting. Suppose you have written int a semicolon. This is your line of code in your C programming language. Okay, so what does it mean? It will check against, here it is, it will check against the source code grammar. So as you know that it is nothing but a compiler. So compiler must follow some rules and regulations, that is known as grammar of the compiler. So it will check whether I have written the syntax in grammatical manner or not. That is, the parcel checks if the expression made by the tokens is syntactically correct or not. So suppose instead of writing int a semicolon. It is correct, we all know. But instead of writing, I have written in and then given that space, then t, and then given the space, then a, then semicolon. So what do you mean by this? So first of all, in this int, it is nothing but the int, that is a data type, that you can say the predefined keywords. Okay, it is a valid keyword, but here it is what? In, because the sequence of character, that is tokens, ends when there is a space. So after in there is a space, there is a space, a small space here. That's why in will be taken as a token, and t is taken as another token, a will be taken as another token, and a semicolon will be taken as another token. So in this way in will be taken as another token. But in does mean anything? No, in does not mean anything in the compilation process. That's why the syntax analyzer will generate an error code. Okay, there will be that error code will be showing to the programmer, and they will be shown that the in is not a predefined keyword. In that way, the error will be generated to the end user or the programmer that will be programming the C programming language. In this way, the phase of this is nothing but this two is nothing but the simple logic, but this last one is the function of the syntax analyzer, that it just checks whether the expression we have written in the language is according to the grammar or not. So that's it. So syntax analyzer, after checking it, will generate the parse tree, and it will go into the semantic analyzer phase and in an input. So let us move on to the semantic analyzer phase. Okay. Now semantic analyzer phase. Semantic analysis checks whether the parse tree constructed follows the rules of language or not. So after verifying the syntax, tokens, lexemes, it will generate the parse tree, and it will check whether the parse tree is constructed following the rules of language or not. So in the next point is that the semantic analyzer keeps track of identifiers, their types and expressions, whether the identifiers are declared before use or not. What does it mean? So let me make you understand. So suppose we have written a and semicolon. It will generate an error code or not? Yes, it will generate, because it has not been initiated. It has not been declared before initiation. Okay, suppose you want to write a equal to 10, you want to write the assignment line of code, but it will generate an error code because in the program you have not declared the a. So you will have to declare which type of a is it. So it is of int data type, so int a, and then you can initiate it, or you can initiate it later on as well. So it will check. So in this way it will check their types and whether identifiers are declared before use or not. Means before initiation, whether I have declared it is of what type, integer type, floating type, boolean type or not. So in this way we have to check in the semantic analyzer phase. Okay. Now the third point is that the semantic analyzer produces an annotated syntax tree as an output. Annotated means nothing else than the verified syntax tree or verified parse tree. That's it. So each and everything, the third point is generating the function of the phase, and the first 2 point is telling about the logics. What are the inputs, what are the outputs, what is it. Okay, so in this way these all points are written. Okay, let us move on to the next phase, that is the intermediate code generator. So I have already told you that intermediate code generator will take the verified parse tree as an input, and it will generate the intermediate code or relocatable code. Now let us move on to the first point, is that intermediate code can translate the source program into the machine program. Yes, relocatable machine code means it can translate the source program into machine program, means it will generate the machine program, machine code. It will generate the relocatable machine code. Now, in the second point is that intermediate code is generated because the compiler can't generate machine code directly in one pass. Therefore, first it converts the source program into the intermediate code, which performs efficient generation of machine code further. So, now here it is the use of why we need the intermediate code generator part, because machine cannot, because the compiler cannot generate the machine code directly. That's why we need to generate the intermediate code first of all, then only we can generate the machine code further. That's written over here. Now the third point is that an intermediate code can be represented in the form of postfix notation, syntax tree, directed cycle graph, tree address code. It is a three address code. Okay, yes, it is written correctly. Three address code, quadruples and triples. So what does it mean? So as you have discussed, as you have taught the data structure and algorithm, so in that the postfix prefix notations are already taught, but for the time being now you can understand that intermediate code generator can be represented in the form of postfix notation, syntax tree, directed acyclic graph, three address code. So intermediate code generator will generate the three address code for the time being now you can suppose it. Okay, that's it. So it is the function of the intermediate code generator. Now let us move on to the next phase, that is code optimization. So the three address code will be taken as an input to the code optimizer, and it will generate what? The code optimizer will optimize the code whether there is any chance or not. So this is the first and last phase that is optional in the compilation process. If the question is being asked to you that what is the phase which is optional in the compilation of the program, then you will need to answer that the code optimizer is that phase which is optional in the compilation of the program. Now the first point is that the code optimization in the synthesis phase is a program transformation technique. So it is the nothing but the synthesis phase, which is a program transformation technique. And number two is that it tries to improve the intermediate code by making it consume fewer resources, CPU memory, so that faster running machine code will result. So let us take one example, that you have written a program of 100 lines, and there is any chance of minimizing the lines of codes of your program, then that minimization will come under this process, that is code optimizer process. And after minimization your program consists of only 90 to 90 or 80 lines of codes. So these reduced lines of codes or program is known as optimized source program. So this is the function of code optimizer, we can say. Okay, now let us move on to the next phase, code generator. Now optimized code will be taken as an input to that code optimizer, and the first point is saying that code generation can be considered as the final phase of the compilation. So the first phase of compilation is the lexical analysis phase, and the last phase of compilation is the code generator phase. Why? Because it is the last phase which will generate the target code. Code generator converts the intermediate representation of source code into a form that can be readily executed by machine. Now, the code generator ultimately generates machine code or target code. Target code is also known as machine code, or machine code is also known as target code because why we are compiling the source program in order to target what, in order to optimize, in order to generate the machine code. So our main code, our targeted code is to generate the machine code. That's why machine code is also known as target code. So target code is not the code that we need to target someone. Okay, it is not in that way. Okay, now error handler and symbol table manager, here is the few definition you may write in your copy. Error handler, it detects error and saves those and prints those back as an error. As I have told you that it will just show the error code to the programmer, that the programmer will understand the types of error and will resolve the error. So it collected to all phases of compiler. It is collected to all phases of compiler. So it means that it is connected to all phases of compiler, means error handler is not in that way error handler is only connected to the first phase. It is connected to all phases of compiler, which defines or which signifies that each and every phase of compiler may generate the error or warning. So which is very very important logic of that things. Okay, now in the next, symbol manager, symbol table manager. So all valid symbols are stored here, and it is used to verify whether the programs uses valid symbol or not. It is connected to all phases of compiler, as I have already told you in the first in the beginning of the video, that a symbol table manager stores the symbol and verifies whether the grammar or syntax or program which is written in the PC is according to the symbol table manager or not. That is a valid symbol, because suppose there is no any concept of symbol table manager, then there will be argument in between two programmer, that one programmer will be telling that this symbol is valid, another will be telling this symbol is valid. Now that's why the symbol table manager is taken as an consideration into the compilation process in order to avoid these types of argument. That's why each and every programmer needs to follow these all rules and regulations in order to create their respective programs. Okay, so now at last, there is a translation of an assignment which will be discussed in the next video, but for the time being now, it is what we have discussed is that different phases of compiler, their respective inputs and outputs and their respective functions, what is error handler, what is symbol table manager, and at last we have generated our target program, that is the machine code. That's why the compiler is need into the consideration. Okay, thank you for watching, and if you like the video, you can like it by giving a thumb, and if you like to share it, then you can share it to those engineering students who needs it most. Okay, and after subscription, you can get the notification of the upcoming videos. If you want to get the notification, you can click on the bell icon. Okay, thank you very